Alright guys, in this tutorial I want to quickly look at class diagrams. So over here in the right corner we have a class diagram and some terminology on at the top and at the left of the slide. So let's first just understand what is a class diagram, then we'll look at what is specialization and what is generalization, which is what we're seeing on this class diagram. So a class diagram is the backbone of object-oriented modeling in the UML, so in Unified Modeling Language. So it maps out the static structure of a software system by showing the system's classes, their internal details, and how they relate to one another before you actually write the code for these classes. So it looks very similar to our the entities look very similar to the classes here looks very similar to our entities from our entity relationship diagram, but they are divided into three sections. So you have your name of your class at the very top, then you have your attributes, and then you have your methods or functions. So we have three classes. Right? We've got student, we've got postgraduate student, and we've got undergraduate student. Then for the student, we have the following properties or attributes: student number, student first name, and student last name. So you will see that the attributes are usually indicated with a minus sign, and this means they are private attributes, which means only the student class has access to its attributes. And the third section of this class lists the methods for this class. So we've got register, where we can register a student, and graduate. So this is usually the functions. And in general, you would pass parameters through in the brackets, and you would say the data type that the function is returning. But for now, I just need you to understand that a class in a class diagram has three distinct parts: in the name, the attributes, and the methods. The attributes are private with minus signs, and the methods, the functions, are public with plus signs. And this means that other classes can access this class's attributes only through its methods. It cannot access the attributes directly. So let's look at specialization. So specialization is the process of taking an existing superclass and creating a highly specific subclass or subclasses, and this is also called child classes. So the subclass inherits the general traits, but can add their own unique attributes and behavior. So if we look at this, our subclasses would be postgraduate student and undergraduate student. Our superclass or base class would be student. This means that a postgraduate student has a student number, has a student name, first name, has a student last name, it has a register method, and it has a graduate method. But it also has unique properties of its own, in addition to the properties and functionality of its base class. So, for example, a postgraduate student, the properties or data we might want for it is the undergraduate university, so the university where the student did their undergraduate qualification, and a progress report, for example. And then a method, for example, could be to submit a dissertation. Then an undergrad student the properties will differ a bit, because we don't want to know the undergrad university because they have not completed their undergraduate studies yet. So, for example, the properties we would have for an undergrad student is the year of study and the intended majors, such as computer science. And the functionality for this undergraduate student might be, for example, to load the major. So if you read this diagram, this class diagram, you can see it is the superclass or base class is student, and the subclasses that is created from the student base class is the postgraduate student and the undergraduate student. The two subclasses has all the properties of the superclass as well as the methods of the superclass. It also has their own unique attributes, properties, and its own unique methods that is unique to that class itself. Now, specialization and generalization is shown with the connecting lines and an open arrow pointing from the superclass to the subclass. And generalization is just it's just the reverse. So so we looked at it from a top-down approach for the specialization, where we created a postgraduate student and we created a undergraduate student class from a base class called student. But if we do generalization, we look at multiple distinct classes, identifying their attributes and operations that they have in common, and then extracting those into a broader shared superclass. So we're working in reverse. So let's say we started with postgraduate student as a class, and we started with undergraduate student as a class, as its own classes. And we saw both of these classes have student number, student first name, student last name, both of them register, and both of them graduate. So instead of duplicating functionalities and attributes, we decided let's create a superclass that has those shared attributes and functionality that is shared by both the postgraduate student and the undergraduate student. And let's only keep what is unique to the undergraduate student and the postgraduate student. Only the unique attributes and the unique functionality for each of them. And then then we create the student class with the attributes that are in common and the functions that are in common, and we're only left with the properties or attributes and functionality for the subclasses that are unique to them. So generalization is just a bottom-up approach where we start with individual classes where we see, okay, they share the same attributes and functionalities, and then we take those shared attributes and functionalities and create a superclass. Okay. Now, I also want you guys to know about composition. So composition is a strict type of a has-a relationship in a UML class diagram. So it represents a scenario where the part is completely dependent on the whole for its existence. So composition is indicated with the black diamond that you can see here. And how we can read this is, so has a part, right? Desktop has a processor and has casing, right? And we say that that it is a composition because we wouldn't necessarily use casing or a processor on its own. It needs to be part of a desktop. So it represents a scenario where the part is completely dependent on the whole for its existence. So this depends on the scenario for your information system, but this example kind of explains that we are focusing on a desktop, which is your PC, and we're not focusing on individual processors and casings. That's not our main goal for our information system. Might be selling desktops, and each desktop has a specific processor and a specific casing, which you can change the color, the size, and for the processor, the brand, and the serial number. So it just says that a processor and casing should not exist without the desktop class. So I want you guys to practice this. This is a practice scenario for you to create your own class diagram. And then on the next slide that I've shared, you will see the answer for this. But essentially, let's just quickly take a look. So in a healthcare management system designed to monitor hospital operations, including tracking staff assignments and on-call schedules, you are tasked with modeling the relationship between different hospital personnel. Specifically, the UML class diagram must capture the hierarchy and relationships of hospital staff, which can either be a doctor or a ward manager. So each hospital staff member has a first name. So here we see the attributes, right? We see hospital staff can either be a doctor or a ward member. So there are two classes that I can see. And now each hospital staff member has a first name, last name, and an email address. So here I can see a super class that is shares these attributes. Then the hospital staff class represents an individual and is associated with another class encapsulating their next of kin. So for next of kin and encapsulating tells me that a next of kin won't exist without an hospital staff member. So there won't be a need to capture a next of kin details if there's not a hospital staff for that next of kin. So there I would see is a part of relationship that we just looked at in the previous one, which is the composition. So here I can see composition. So which includes attributes for the nickname, kin name, sorry, relation, and contact number. So these will be individual attributes for that class next of kin. So the next of kin class must include a method to return the full kin contact string. The hospital staff class should include a method to return the basic info of a particular staff member. A staff member is normally associated with exactly one next of kin. And then the doctor subclass, so here it already tells us that we are going to need to use generalization. If we see subclass or superclass or base class, then we know we're going to have to use generalization. So it includes attributes like license number, speciality, years of experience, and on-call status. So these will be attributes for the doctor subclass. While the ward manager subclass includes manager ID, ward name, and desk extension. So this gives us our attributes for our two subclasses, which is going to be doctor and ward manager. And our superclass might be the hospital staff. And then each hospital staff member would be linked to a next of kin, exactly one next of kin. And here we have the attributes for the next of kin and the methods that is needed for the next of kin. Then we see the methods specifically for the doctor. The doctor class should include methods to return data regarding the doctor and the speciality they practice. And the ward manager class should include the methods to return the manager's details and their associated ward. So let's take a look at it. So here we see our super class, which is hospital staff, first name, last name, because both the doctor and the ward manager will have a first name, last name, and an email address. And remember, in our instructions or description or scenario, it specified that we need to get the basic information of any hospital staff member. Then the scenario indicated that there's going to be two subclasses of a hospital staff, a doctor and a ward manager. So a doctor inherits the properties from a hospital staff and has its own properties and attributes and functionality. That was in the scenario. The license number, speciality, and this POE status is a mistake there. The get doctor data, the get speciality data, and for ward manager, we've got attributes like the manager ID, ward name, office number, and these are the functionalities that we needed to include for the ward manager based on our scenario. So to get the manager details and to get the ward. And here we can see our next of kin. And we said it is a composition to the hospital staff. So a next of kin does not exist without a hospital staff member. So it's linked directly to a hospital staff member indicated by the black diamond. And these are the attributes: kin name, relation, contact number for the next of kin. And this is the functionality: get full kin contact of that class. All right, guys. Thank you.